All right, today we're talking about 2.2, which is logic. This is going to seem a lot different than any other math problem that you've probably done before. That's kind of part of the deal with geometry. So we're looking at truth values and negations, conjunctions, disjunctions, and using Venn diagrams. So all kinds of stuff we're looking at here. So we have some vocab. So we have a statement, which is something that's either true or false. The truth value is whether it is true or false. The negation is the opposite meaning, and it uses this little symbol right here. So you'll see me draw this. That means not. That's the negation. A compound statement is joined by and or. When it's and, it's a conjunction, and both parts must be true for it to be true, and they use this symbol, the upside down V, for and. A disjunction is the or statement, and it says at least one part of it must be true. So they use the V, the right side up V, for that one. And these are steps to make a truth table. And a truth table is used to tell when you have a complicated set of compound statements to be able to tell if they're true or not. So start out basic here. It says use the following statement to write compound statement for each conjunction, then find its truth value and explain your reasoning. So these are our little statements. We have statement P, statement Q, and statement R. So P says 1 foot is 14 inches. Okay. Q says September has 30 days. And R says a plane is defined by 3 non-collinear points. So P and Q is the first piece that we want to check. So we want to see if P and Q, if both of them are true, because this is an and, which means they both have to be true. I think about it as like if I say I go to McDonald's and Taco Bell, that means I went to both of them. I had to go to both in order to make that statement true. I couldn't just go to McDonald's and say I went to both. So first one, P is not true. So if I look at Q is true. But since one of them is false, that means that the whole statement is false. Because of the fact that this was an and statement, I'm saying that both of these things have to be true. This has to be true and this has to be true in order for the whole statement to be true. So on here, B, we have not P and Q. Sorry, not P and Q we have here. So not P means that 1 foot is not 14 inches. So if 1 foot is not 14 inches, that's true. Q, September has 30 days. We already said that that is true, so I'm going to say and September has 30 days. So that we already know is true. So since they're both true, this whole statement is true. Sorry, that doesn't look like true at all. Fix that. There we go. All right, so I guess we didn't need R there, did we? All right, example 2 says use the following statements to write the compound statement for each disjunction. So now that it's a disjunction, these are the or statements. The conjunctions are the and statements. The disjunctions are the or statements. So in order for it to be true being an or statement, only one or the other has to be true. So like if I said I went to McDonald's or I went to Taco Bell, and I went to one of them, then that statement's true because I went to one or the other. So we have AB is the proper notation for segment AB, so that's correct. We have cm is a metric measurement, so centimeters is a metric measurement. So this one's true, this one's true. 9 is a prime number. Ooh, that's a tricky one because a lot of people think 9 is a prime number. That one's false because 9 is divisible by 3. So P or Q, are those true? So I'm going to say, since I have a true and a true, that means that they are both true. So since they're both true, P or Q is also true. Here I have Q or V. So remember, this means or. Sorry, Q or R. Said that incorrectly. So Q was true and R was false. But since at least one of them is true, then that means this is true, because this is saying centimeters is a metric measurement or 9's a prime number. Are one of those things true? So since one is true, so since Q is true, then Q or R is true. So now I have not P or R. So not P would be the opposite of this. Not P would be saying AB is not the proper notation for segment AB. So not P is false, and R is false. So not P or R is false. So that means I was lying on both of them. If I said I went to McDonald's or Taco Bell and I went to Wendy's, then I was lying on both of them, so that statement is false. Okay, so now looking at truth tables. Oh, sorry, not to truth tables yet. We are making a truth table for each compound statement. So a truth table, let's go back up and read these really quick. So these are the steps to make truth tables. So we want to make columns with the headings that include the original statement, any negations of these statements, and the compound statement itself. So on this one, I'm going to have P, Q, not P, that's the negation, and then the statement itself. So these are going to be my columns. Step 2 says list the possible combinations of truth values. So in here, I'm looking at, for these two, what are the possible combinations? So I could have, they're both true. I could have true, false. I could have false, true, or I could have false, false. Those would be the possible options. Not P is just the opposite of the ones that we listed here. So if this was true, then this one has to be false. If that's true, that has to be false. This would be true, this would be true. So I just switched those. So now I'm looking at not P or Q. So I'm saying these two I'm looking at now. So I'm going to actually kind of highlight these. So we are now looking at these two columns because I have not P or Q on here. So are either one of these true, since it's an or statement? So since I have a true there, this would be true. Here I have false, false. So that has to be false. Here I have true, true. So that's true. Here I have false, true. So since I have at least one true in there, and this is an or statement, that one will be true. So you're using that, this is what a truth table looks like then, to figure those out. So this one, part B, is a little bit longer here. So we have, I'm going to use some space up here. So I have to have P, Q, and R, because those are all my originals. I have to have not Q, because that's one of them in there. And then I have to have not Q and R. And then at the end, I want the whole thing. So I have P, or, not Q, and R. Whew, this is going to be a long one. Get yourself ready. Okay, so now we're going to list out all these possibilities, and there's going to be a bunch of them. So I have true, true, true. I could have two trues and a false, and that false could move. Okay, now I could have two falses and a true. And then I could have three truths. I think that's all of them. Yep. So now we have not Q. So I'm going to take all my Q's here and I'm going to switch what those are. So this is going to become F, F, T, F, T, F, T, F. Okay. Now I have not Q and R. So that means that in order for this to be true, these both have to be true. So if it's an and I'm saying that they're both true here. So where I don't have two trues here, so that's false. False. Here I have both trues. False, false, false. Both trues and another false. And now the last one, P or, not Q and R. Whew. So now I'm looking at the P and this column. So I'm just looking here and here. And if it's an or, did I do the or? Oh, I already did that piece. Sorry. This is the or. If it's an or, it means just one or the other of them has to be true. So here I have one true. Here I have a true. Here I have both trues. Here I have both falses. So that one's going to be false. Here I have a true. Both false. A true. And a true. Whew. All right, we will definitely practice those more. So don't freak out if you're looking at this going, oh my God, what are all these T's and F's? We'll practice it more in class. All right, so one more. This one isn't bad, I swear. So we have a Venn diagram, and we're showing people that are enrolled in the dance class. We have tap, jazz, and ballet. So Venn diagram here. How many students are enrolled in all three classes? So all three classes would be where all these circles intersect each other, and that would be right here, which is the 9. 9 students. Okay, part B says how many students are enrolled in tap or ballet. So if I look at this, I have all of these kids are in tap and all of these kids are in ballet. So I need to take all those numbers that are in there and add them all together. So I have a 28, a 13, a 9, a 17, a 25, and a 29. And if I add all those together, that gives me 121 students. And part C says how many students are enrolled in jazz